with a rational function. The best case scenario is that we have, these are not best case. Best case scenario is, this is not in your notes, we're just taking down some main ideas. Best case scenario is we have something like 5x squared plus 9x minus 8 over 4x squared plus 2x plus 3. That is the very best case because the degree of the top and the bottom are the same. And then your end behavior asymptote is just going to be the horizontal line, y equals 5 volts. That is the easiest situation. The next easiest situation is when you have something like this, 3x minus 2 over 5x squared plus 9. What is that end behavior asymptote? What is happening with that function? It's going to 0. This is going to 0. Think about it. They're both getting big. As x approaches infinity, they're both getting big, but which one's getting bigger? Faster. The bottom. And when you have a fraction that is growing faster on the bottom, that means the denominator is getting bigger, then the fraction itself is getting smaller. Think of it like this. There's no x squared up there to balance out the one on the bottom. So your asymptote is going to be y equals 0. So those are the two easiest situations. Powers are the same, or the big powers on the bottom. They don't match, but the big one's on the bottom. That is the easiest. Now, when you have a situation like this one, where the top is growing faster than the bottom, does that make sense to you in this fraction? There is no x squared to balance out, there's no x squared in the bottom to balance out the one on the top. So you end up with comparing 2 over 0, which of course we know is undefined. Now that means that the curve is shooting off into space. It's not like approaching anything, it's shooting off into space. When the degree of the top is bigger, that's what's going to happen. When the difference in the degrees is just 1, so when the top degree is 1 bigger than the bottom, you're going to have what we call a slant asymptote. And to find that slant asymptote, it's really easy. You're simply going to divide the top by the bottom. Now, I've got an example in each here because there's 2 ways to divide polynomials. Do you know what I'm talking about? Long division, which is what I'm going to do here. And then what's the other way? Synthetic division. Did you do that last year? Okay, so you remember how that works. So if we're going to do this with synthetic division, we're going to have a little box out here. I use a box. I don't know what you did. You have a little thing out here. And you put -3 in that box. So you put the opposite of the number that you're dividing by. So it's x plus 3, so I put -3. And then I write down my coefficients. So 2, 4, -1. Okay? And then I draw a line, leaving a space there. You see what I'm doing? I put some numbers in there. And this guy comes straight down. So then we take -3 times 2 and write the answer here, -3 times 2. Then we add, then we do -3 times -2, write the answer here, and add. Is that looking familiar? Do you remember doing that? Good. Now, what does this mean? Well, remember to do all this, we took out the letters. Now we gotta put them back in to get the answer. We put them back in. But since we divided a 2x squared by an x, guess what this first power is? It's not x squared anymore. It is just x. So what I have left here is 2x minus 2. What's that?
5 over x.
The remainder. That's the remainder. And in slant asymptote land, we don't care about that. All we care about is this right here. that line is your slant asymptote. So the curve is going to get closer and closer to that line as it goes off the page. Now, I love synthetic division, but it doesn't always work. It's not going to work when you have all these powers here, that one right there in particular. So this one would have to be done with long division, and I don't have time to do that, so I'm going to have to pause. But you understand why this is going to have a slant asymptote. The top power is 3, the bottom one's 2, there's a difference of 1. Anytime there's a difference of 1, you're going to have, when the top is bigger, you're going to have a slant asymptote.